In this video, I want to have a look at algebraic methods for solving simultaneous equations when one equation is linear and the other one is not. So it can be a circle, a parabola, any sort of curve. So our first example is going to be, our first curve is y equals 2x plus 3. And our other curve is y equals x squared. So we have a straight line and we have a parabola. Now, when we were solving linear equations before, or simultaneous equations, we had two options. We could either do it by substitution or elimination. When one of them is non-linear, substitution is almost always easier. So we'll go with that. The first thing you need to remember to do is number our equations. So we'll call it equation 1 and equation 2. Because we know that y is equal to 2x plus 3 and y is also equal to x squared, then these two things have to be equal to each other. 2x plus 3 has to be equal to x squared as well. So we can either substitute equation 1 into equation 2 or equation 2 into equation 1. It doesn't matter which way we go. But we'll just write down what we're doing. So let's sub 2 into 1. We'll end up with the same thing if we did it the other way as well. So equation 2 tells us that y is equal to x squared. Because we're going to put that in where y is in equation 2, we'll have x squared is equal to 2x plus 3. So this is good because now we only have x's, we don't have x's and y's, and now we can solve it like a normal equation. So we'll pull all our unknowns over to one side of the equation. So that means we'd have to subtract the 2x and subtract the 3 from both sides, and we'd end up with 0 over here. And now it looks like a quadratic equation. So now we can factorize that. Go to x. We need two things that multiply to give negative 3 and add to give minus 2, which should be minus 3 and minus 1. No, plus 1. So that's equal to 0. So that means that either this or this has to equal 0. So we've either got x minus 3 is equal to 0, or x plus 1 is equal to 0, which means that x is equal to 3 or x is equal to minus 1. So now we've got the x coordinates of both our points of intersection. Now we need to figure out what the y coordinates are as well. So we'll substitute x equals 3 and x equals minus 1 into one of these equations. Doesn't matter which one we pick again. So if we sub x equals 3 into equation 2, then we'd have y is equal to 3 squared, which is equal to 9. If we do for the other point, so sub x equals minus 1 into equation 2, we'd have y equals minus 1 squared, which is equal to 1. So our points of intersection are 3, 9, and minus 1, 1. And we can actually check those as well if we were to graph it like we were doing last lesson, and it would come out looking something like this. So you can check your answers. We had 3, 9, which is this point here, 3, 9, up here where they cross over, and we had minus 1, 1 as well. So minus 1, 1. So we did it right.